We're going to talk about something huge, how our cities are being totally re-engineered, I mean, from the ground up. We're way past those little isolated smart city experiments. What we're seeing now is the start of these massive citywide digital frameworks, the kind that manage everything from your morning commute to when your trash gets picked up. So yeah, let's get right into it.
So you might be asking, why should I care about this right now? Well, how about this for an answer? Over $1 trillion. Yeah, that's the estimated global market for smart city tech in 2025. This is absolutely not some niche little industry anymore. It is a massive economic wave that's changing pretty much every part of how we live in a city.
Okay, but here's where it gets really interesting when you start to break down that $1 trillion number. I mean, the whole market is growing at a pretty solid 4%, but look closer. The platforms, the software that connects all this data, that's growing at 10%. And smart waste management, get this, it's exploding at a 16% compound annual growth rate. So the takeaway here is pretty clear. The real action, the real growth is in the brains of the operation, the software and the specialized systems that make everything run smarter.
So to really get a handle on how this all works, we got to start with the basics. How does a smart city even communicate? The best way to think about it is like a nervous system for the whole city. It's this complex web that's constantly sensing what's going on and zipping that information around in real time.
And this nervous system, it's basically built on 4 layers. It all starts down at street level, right? That's the sensor layer. This is what's grabbing the data. Think of a sensor that spots a full trash can or detects a traffic jam. From there, that data has to travel up through the network layer. Then it hits the analysis layer, where the system figures out what it all means. And finally, you get to the application layer, which is where something actually happens. A garbage truck gets dispatched or a traffic light changes. It sounds simple, right? But it's so powerful.
Now, picking that network layer, that's a huge decision. It's a real balancing act, especially with these things called low-power wide area networks, or LPWANs. See, on one hand, you've got tech like LoRaWAN. It's cheap, it's got great range, and it's perfect for stuff that isn't life or death, like smart streetlights or air quality sensors. But then, on the other hand, for the really critical stuff, like your water supply, you absolutely need the high reliability you get from something like narrowband IoT. That runs on a secure, licensed network, so you know it's going to work.
And really, this is a great look at the whole toolbox cities have at their disposal. It's never just one size fits all. It's a whole mix, right? You've got your short-range Wi-Fi inside smart buildings. You've got those LPWANs we just talked about for things like water meters. Then you've got super-fast 5G for things that need instant communication like self-driving cars. And you even have satellites for keeping an eye on stuff that's way out there. It's all about picking the right tool for the right job.
Okay, so we've covered how the city talks to itself. But just connecting a bunch of stuff, that's only step 1. The real game changer, the revolution, happens when all those connected things actually start to think. And that, my friends, is where AI meets the Internet of Things.
This combo has a name, AIoT, or the artificial intelligence of things. And if there's one thing to remember, it's this. AIoT takes the Internet of Things from being a system that just collects data and tells you, hey, this happened, to a system that can actually learn, predict what's about to happen, and then do something about it, all on its own.
So what's the #1 job for this new tech in our cities? You might think it's something really flashy, right? But check this out. A whopping 2/3 of all use cases are for something called predictive maintenance. Its main job, right now, is basically just to figure out when a really important piece of equipment is going to break, before it breaks. And here's the thing. It is crazy effective. We're talking about AI-powered systems that are already hitting over 90% accuracy in predicting when something's going to go wrong with critical infrastructure. We're talking the energy grid, the subway system. I mean, this is literally the stuff that keeps your lights on and gets you to work on time. And this quote right here, it just nails the huge shift in thinking. The primary constraint on city management is no longer staffing cycles or administrative paperwork, but latency. So what does that really mean? It means in a truly smart city, the biggest bottleneck isn't people or paperwork anymore. It's all about speed. It's about how fast that city nervous system can spot something happening and react to it.
All right, so that's the tech. Enough theory. Let's look at how this stuff is actually being put to work solving real problems in real cities all over the world. This is where it gets tangible.
Let's do a quick trip around the globe. You've got Enschede in the Netherlands using digital models to tackle city heat waves. Over in Germany, Aachen is running traffic simulations to get rid of gridlock. Singapore, they're setting the gold standard for public transportation. And Barcelona is all in on using IoT for smarter water and waste management. It's happening everywhere.
But if you want a really, really dramatic example, you have to look at Bergen, Norway. They installed this wild pneumatic waste system that literally vacuums trash through underground tubes. The result? They've cut the number of garbage truck runs by an incredible 90%. Just think about that. The drop in emissions, the noise, the traffic. It's a huge deal.
And you see these kinds of efficiency gains pretty much everywhere you look. We're seeing smart systems slash energy use in buildings by up to 35%. They're easing congestion on the power grid by 40%. They're even saving 25% of the water for city parks. These aren't just small tweaks. These are major, measurable steps towards being more sustainable.
Now, one of the coolest, most futuristic tools making all this happen is something called a digital twin. Seriously, just picture a live, virtual copy of the entire city. It's almost like a hyper-realistic video game, but it's constantly being updated with real-time data from thousands of sensors out in the real world. City planners can use this thing to run simulations and manage the city with a level of precision we've never seen before.
And it's already evolving. The next step is something called Gen Twin, which brings in generative AI, the same kind of tech that powers things like ChatGPT. What this means is that a city manager doesn't have to be a data scientist anymore. They can just ask the city a question in plain English. Hey, what's going to happen to traffic if we shut down this bridge for a week? And boom, they get a full simulation. It basically opens up all this incredibly complex data to way more people.
Okay, so let's zoom out for a second and look at the bigger picture here. As we're barreling towards 2040, we really have to think about the human side of all this. What does it actually mean to live in a world that's this connected? What are the implications for society?
And this really is the core issue, isn't it? It's a classic double-edged sword. On one side, you have the promise of amazing new efficiencies and a better quality of life. But on the other side, you have the danger. You have very real, very serious concerns about surveillance, about privacy, and about who actually owns and controls all this data. And this isn't some far-off sci-fi problem. This is a debate that's happening in city halls today.
So how do cities build that trust? Well, many are using this very same technology to give people a voice. In Helsinki, residents can actually vote on how parts of the city budget are spent. In a place called Peachtree Corners, Georgia, there's an app where you can report problems instantly. Barcelona has this amazing platform for digital democracy. And look, these aren't just cute features. They are absolutely essential for making sure that this powerful technology is actually working for the people it's supposed to serve.
And of course, there's another massive challenge: security. When you have billions of devices running your city's most critical infrastructure, security has to be priority number one. The attack surface, as they call it, which is just every single connected device, from a traffic light to a water pump, is enormous. One weak spot could cause chaos. So the response has to be multi-layered. You've got new laws, you have to manage security for every single device from the day it's installed to the day it's thrown out, and you use AI to constantly hunt for threats by spotting anything that looks out of the ordinary.
So where is all this headed? What's the long-term vision? Well, think about this. In 2018, we had about 10 billion connected devices. Today, AI-native infrastructure is becoming the new normal. By 2040, we could be looking at trillions of devices powering what some people are calling life weaver cities. The whole idea is that technology becomes so integrated, so woven into the fabric of the city, that it's like a living ecosystem that adapts to us, anticipating our needs and meeting them, maybe even before we know we have them.
And that brings us to the final and maybe the most important question of all. This technology is incredibly powerful. Its potential is just immense. But as our cities literally become living, breathing data ecosystems, how do we make absolutely sure that they are built to serve people and not just the systems themselves?